Okay, it's November the 22nd already. It's Thanksgiving in America. Tonight, our hosts are Maarten van Stam, that's me, and Fanie Reynders. And we have a special guest today. It's Bryan Costanich, or Costanich. How do you say it?
Costanich.
Costanich, okay. And we are going to talk about this crazy Kickstarter Meadow project by Wilderness Labs and maybe some other items, but this will be our main thing for today. And then I kick in the leader. Hello, Bryan. How are you?
I'm fantastic. How are you guys?
Ooh, yeah.
Very, very well done. Very, very cold though.
It's that time of year. I'm looking forward to lots of hot food though today. It's Thanksgiving, so I'm going to stuff myself with pies and turkey.
Nice. Well, tomorrow,
11 o'clock, I think, a.m. in the morning.
That's right.
Yeah. We're in the evening, so if we had a Thanksgiving, then we would have killed the turkey already.
Cold turkey in this case.
Cold turkey. So, yes, and maybe you can introduce yourself a bit for our audience.
Yeah, absolutely. So I'm Bryan Costanich. I am the CEO and co-founder of Wilderness Labs, and we are setting out to revolutionize IoT. We want to make hardware development as fast and easy as software. You know, as fast and easy as software development goes. So everyone knows software development's hard, but you know, hardware development is just beyond hard today.
And you were previously working for Xamarin, I believe.
That's right. Yeah, that's right. From just about day one.
Oh, so early adopters then.
Yeah. In fact, I wrote a book on monotouch before Xamarin was Xamarin, when it was back in the Novell days, and that's how I wound up at Xamarin.
Oh, really?
Yeah. So I built the documentation team over there, and then I built Xamarin University, and then helped drive strategy and stuff at Xamarin.
The old Xamarin guy.
Yeah, that's right. That's right. When I started, I think there were 7 people.
Yeah, and then Microsoft, they just took all things over, and then you left.
That's right. Yeah. So I transitioned my team over and got everything kind of set up and situated there, and then started another company.
Oh.
And I believe the company's name is Meadow, right? So can you tell us more about Meadow?
Yeah, absolutely. So company's Wilderness Labs, and the product that we're launching is Meadow. And Meadow is a full stack IoT platform that runs on microcontrollers. So basically what we've done is that we've enabled full .NET development on very, very, very tiny chips, the type of chips, microcontrollers that power IoT today and will, be the dominant form of computing over the next couple of years. Okay. And we've got, full stack. So operating system and driver library and hardware APIs, etc. So the whole thing.
So that's a different beast than the Windows 10 IoT thing, is it?
Yeah, it's a bit different. Windows 10 IoT is interesting, but it doesn't run on real IoT hardware. It runs on application processors. It doesn't run on microcontrollers. It requires a full Linux subsystem, which is a multi-user, multi-app paradigm, and that's just really not what IoT is powered by. IoT is powered by microcontrollers with real-time micro operating systems, and it's like a different sort of class of computing. And of course, the price point is different for embedding. So microcontroller might run anywhere from $3 to $10 to $12, whereas like an application processor that of the type that like Windows IoT runs anywhere from like 20 to 50 to $60.
I found on the internet, this this video with you with James Montemagno, and you showing the net. What's the
NetDuino, that's right. We acquired NetDuino a couple of years ago as we started Wilderness Labs, and we used NetDuino as a forcing function for us to build a hardware company, to create a place for Meadow to land in. So we always knew that we were wanting to build Meadow, but NetDuino was going to go away. And I had an opportunity to purchase it, and so we acquired NetDuino, and we did a lot of prototyping with NetDuino and a lot of learning, and and NetDuino was an opportunity for us to set up a hardware development company. So when you're selling hardware, it's a little bit different than software because you have actual physical product, which means that you have to worry about supply chain and distribution and things like that. And so we used NetDuino to learn about all those things while we were building Meadow. And also it was an opportunity to sort of like, give back to the NetDuino community and give NetDuino to the community by, we open sourced everything and said, hey, look, we made this pretty cool, but it's now community. This is the community. And in doing so, we actually built the community and provided a place for Meadow to land, which I think, contributed to why our Kickstarter campaign was so successful.
Or it still is, because you're over budget for 5 times, I think, currently. Let me check quickly.
It's like 85,000
yes,
900 euros.
Yeah, that's right. I think we're almost 400%, almost 4x over our past our funding.
Right. So that was an understatement for popular. Yeah. And as you can see, they are really a lot smaller than the other boards. I have some different board here. I have one of the Raspberry. I have a Raspberry over here. Let's see, that's a lot bigger than that. It's a bit like the one that you showed in the NetDuino in. It's transparent.
Yeah, transparent one.
That's cool.
Special item.
Yeah, so I can show you side by side here for instance, a NetDuino and a Meadow board. Ooh, excuse me. So NetDuino is the old Arduino form factor, and you can see the Meadow board is feather form factor. So it's about a third of the size of NetDuino. It's really just a tiny, beautiful little piece of hardware here. I mean, it's just gorgeous. We're really proud of it.
So let's quickly talk about the components that's on this board. Is it comparable to a Raspberry Pi, or is it something completely different?
That's an interesting comparison because it has basically the power, the functionality of a Raspberry Pi, but it uses roughly 1,000th of the power of the electricity. So it has so integral on the board is it has 32 megs of flash and 16 megs of RAM, and then it's got Wi-Fi and Bluetooth provided by an ESP32 chip. But the main board is powered by an STM32F7 microcontroller, and microcontrollers are very, very powerful but very low energy requirements. And so basically, that chip does nearly everything that you would find in a Raspberry Pi. So it does 2D graphics acceleration, and it has lots of really interesting camera input channels and can drive displays and things like that. And so basically everything that you would expect to find in something like a Pi form factor, you can get it into in this form factor.
And in terms of price, what is this thing going for then?
Yeah, so the development board out the gate is $50 right now, $50 US. And over time, we'll see that drop. And I think in the next couple of years, we'll also release a board based on the ESP32 chip, which is an even a smaller, cheaper, price point cheaper. It's a really fantastic chip, but we think that long term you'll be able to embed Meadow into your products for somewhere between like $5 and $10 a unit.
Cool, and it's completely .NET standard, right? So am I right in saying if I do like a .NET standard piece of code, it will run there.
Yeah, absolutely, absolutely. So we run. So this runs a customized mono runtime on this board, which means that out of the gate you get full .NET Standard 2.0. Now, of course, you actually get more than that. The .NET Standard 2.0 API, or 2.1 now, API surface is a smaller surface area than actually what we provide, because we have the full mono. We have the full mono runtime. So I think that we support whatever the mono's at right now. It's like 4.72 or something.
No idea.
Yeah, it's more than .NET Standard 2, but the idea here is that any NuGet packages that target .NET Standard 2 to 2.1 will run out of the gate on this thing. So if you want to add like cloud connectivity for this or that, or if you want to add JSON, Newtonsoft JSON, you can just drop it in, and other things as well. One of the things that that microcontrollers do really well are local artificial intelligent models. So like machine vision runs really well on a microcontroller. So we want to make it really easy to drop in like TensorFlow Sharp and then run that on here, so that you can do machine vision and categorization of photos and things like that, and add intelligence that way.
Okay, so we actually spoke about a .NET Standard now, and we spoke about Arduino and your board now, and you are familiar with the .NET Micro framework, right? That was
yes.
That came. I don't know if it's still alive yet. Is it somehow usable on this thing, or portable today, or is it nothing to do with this .NET Micro framework?
That's a good question. So the .NET Micro framework was what the NetDuino ran, and a number of boards. And the .NET Micro framework really hasn't seen an update in many, many, many years, and doesn't have a lot of the modern stuff that we would consider as part of .NET. Like, for example, the .NET Micro framework doesn't support generics. And the API surface area is stuck back in kind of like 2002. So Meadow is something completely different. Meadow was a fresh, clean break and a modern take on .NET. And so, I really liked developing on NetDuino, and we took NetDuino, I think, as far as we possibly could. We did some really awesome things with it with NetDuino Foundation and the libraries there and whatnot. But it was always frustrating to me that I couldn't just pull in any old NuGet package or use generics, and it's funny because people say, oh, generics, they're cool, but, they're not, maybe they're not super necessary for embedded programming. But I have to say, in actually building out Meadow and writing code, I am so glad that we have generics and async await and all of the modern things that we have in .NET. So Meadow is really from the ground up, a modern take on embedded programming. And so we said, look, the .NET Micro framework was good for the time, and it was impressive at the time, but really what we wanted to do was full .NET. So we spent the last 2 years getting mono running on this thing, so that we didn't have to deal with all of the limitations of the .NET Micro framework. Now, porting apps from the .NET Micro framework from NetDuino is really pretty easy. It's basically copy paste and change out some names for the ports and whatnot, and then they'll just run. Because we use a lot of the same sort of patterns, but we've upgraded a lot of stuff as well.
I'm just checking out some of the core components, like you have, like the UI, the networks, the protocol communication, security. You basically have everything in there that you need, And if you move up the stack, the sensors like the atmospheric, barometric, compass, camera, it's amazing. And
yeah, except for the screen, but you put that in the hack kit.
Except for the screen. Who needs a screen? It's an IoT. You don't need a screen. You can build dashboards with Power BI or something. That's your screen,
Yeah, I think as you said, it's everything you need. The idea here was that there's a lot of the IoT space is just a mess. Like if you're building IoT today, it's really stuck in the 80s. Most IoT is done in Arduino or Arduino clones like Particle, in which you're writing a lot of low-level wiring C++ code, and you're fighting with drivers, and you're fighting with this or that, or if you're not using Arduino, if you need like more sophisticated, if you need to write more sophisticated apps that have like multi-threading and stuff, then you're absolutely writing like C++, and you're using like ARM embed or these other things, and then you're fighting with operating systems, and you're fighting with CMake, and you're fighting with a lot of this like really old stuff, and I feel like the analogy there is that building IoT today is like building houses, where if you need wood, you have to go to the forest with a saw and cut down some trees and make your own beams and posts and things like that. And if you need some stone, you're sent to the quarry, and you have to go like hew rocks out of the quarry and then shape them to what you need. And so we wanted to take a different approach. I think that I read an article the other day about, how IoT was a mess and how no platform had really everyone was waiting for like the platform for IoT, and we're waiting for that to emerge, and how everyone had basically given up on a platform emerging. And so I think that Meadow is that platform, and the reason why I think that nothing has emerged yet is because it's a really, really hard problem. It's like a hard technical problem, because first of all, what IoT runs on microcontrollers, like throw everything else out the window. Microcontrollers are the things that are the chips, the type of computing, the class of computing that powers IoT, because they can run anywhere. They can run on a coin cell battery. They can run on small solar panel for years. You can put them anywhere because they're small and they're cheap, and they can do everything that like an application processor used to be, that used to be reserved for like an application processor or a CPU. But what we wanted to do is we wanted to bring a really modern experience, a really modern stack to those chips, which meant that we had to think about the whole thing from top to bottom. So if you're going to Adafruit or SparkFun, or you're going to Mouser, and you're buying peripherals, and you're buying screens, and you're buying sensors and things like that, we didn't want you to think about like, okay, how does this thing, like, what is the wiring here? Is this really complicated? And then these protocols, I have to implement these protocols, and there's a lot of like plumbing code there. We just wanted to get rid of all of that. The idea is that you plug it in, you follow our diagrams, and then you get a beautiful API for these things from top to bottom. And as you mentioned, our API includes things like network. So we've abstracted that away. And so when you want to get on a Wi-Fi, you call enumerate Wi-Fi networks, and you connect to your Wi-Fi, and same with security things like over-the-air updates and whatnot. We wanted to make that really, really easy and provide a solution from top to bottom. So that the idea here is that look, sometime in the next decade, there's going to be 10 times as many connected devices in the world that are not mobile phones than there are humans. So there's going to be 75 billion connected devices in something like 6 or 7 years from now. And the only way that this is going to happen, the only way the IoT revolution is going to be possible, is if someone enables developers, app developers, mobile developers, web developers to be able to do hardware. And today, hardware is it requires a specialized skill set, and it is reserved for like the most learned folks in electrical engineering. And those folks are often not software folks, and then the software folks that want to do hardware are not often hardware folks. So the idea here is that if we say, look, you don't need a lot of specialized skill set in either one of these. If you can build a mobile app, if you can build a web app, then we want you to be able to build hardware, because the revolution will be powered by the folks, the engineers that are out there today doing day-to-day development tasks, and day-to-day development tasks and whatnot today are web developers and mobile developers. And even though IoT is the next big computing revolution, that won't happen until it's easy for folks. And so that's what we set out to do. We set out to really make it easy and enable .NET developers that are out there maybe doing Xamarin today or doing ASP.NET. With Meadow, we believe that those folks, if you're out there doing that today, you can build hardware with Meadow.
Yeah, right. So because if some of the people hear IoT, they immediately think breadboards and wires, and then they immediately back off.
Yeah, and not even just breadboards and wires, but like crazy protocols and doing weird low-level memory accessing across wires and things like that. And we say we don't need that. Let's get rid of that. Let's make it easy. You
don't have to learn C. You can just stick to .NET, right?
That's right. You don't have to learn C, and you don't have to learn to be an electrical engineer.
Well, it won't hurt, but you don't have to. Let's just put it that way.
That's right. Absolutely. I think electrical engineers and C developers and stuff will find themselves right at home on our platform. Yeah. In fact, I've been talking to folks they're professional IoT developers today, and they're like, this is exactly what we've been waiting for, because look, I know C++, but I don't want to write this stuff in C++. I don't want to have to rebuild my house every single time, and if I want to connect to the internet, I don't want to have to write network libraries. I don't want to have to write low-level graphics libraries if I need to output information and graphs and and things like that.
Right, exactly.
And how open is this ecosystem? Can a expert go in and write more drivers and put it in your in your ecosystem? Do you have a store?
Yeah, absolutely. So just like NetDuino Foundation, Meadow Foundation will be completely open sourced, and it'll probably be like an MIT or Apache 2 license. And the idea there is that absolutely. So we want to curate and we want to make sure that all of the drivers that are in there are really high quality, that they conform to the contract, so that in humidity sensor, whether it's made by Adafruit or SparkFun or Samsung, that humidity sensor is going to have the same API contract no matter what, and it's going to act the same, and it's going to sort of look the same and talk the same, etc. So we want to make sure that those have there's a really good experience around drivers and around those hardware APIs. And so we'll curate these and we'll control pull requests and stuff, but it's absolutely open source, or will be open source, just like NetDuino Foundation. And the idea there is that not only will you be able to contribute new drivers and be part of this community, but let's say that you're writing a new driver for something that doesn't exist, and you can go and look into the source code and say and see how that we've done it for similar drivers. And one of the things that we've done in there is that we've abstracted a lot of the hardware stuff away. So let me give you an example. A lot of drivers run over various protocols like SPI or I2C. And today, talking to an I2C device means a lot of plumbing code. It's a lot of okay, let's get the address, let's connect to it, let's do some low level shuffling of bits over the wire, and then we have to figure out how to read registers and write registers and stuff like that. With Meadow Foundation, we were like, you know what? Look, we'll expose all of those calls, and if you really want to dive down deep, and if you need to go to the metal, you can. But we have a bunch of high-level calls there. So you create a new I2C based device. You just pass it the address of a device on your I2C network, and it can automatically talk to it. And then if you need information from it, you can just call read register or write register. So no plumbing code. It's just like, new device, here's the address, I want to get this information off of it, done. And so that's all built into Meadow Foundation. And so you'll be able to look into the code and say, okay, I've got this, maybe I'm an OEM building a new humidity and temperature sensor, or maybe I've got something off the shelf that is kind of a specialized and rare device. How do I plug that into Meadow? So you'll be able to go look at existing drivers and basically copy and paste and change a couple of things, and then it should just run.
So let's quickly take a look at a real world example where you take that humidity device. Now you measured it, and now you want to send it up to the cloud. Where would I then store my credentials? Does it have some kind of a TPM module as well, or extension to it that I can? Because obviously I don't want to store it as plain text, right?
Right. So that's a good question. And some of that are things that we still need to solve today. So I don't want to overpromise there, and I don't want to talk about things that we don't have or may not have. But there are some things that you can do. So first of all, the device itself has a ton of security stuff built in, and so there's keys on the device, and there's secure key storage and whatnot. And then we support SSL, so at least for transport security, that's taken care of. So you can push things up to the cloud, and you can and you can make sure that they're encrypted in transport. The other thing is that we do have full encryption with hardware acceleration. So if you need to store stuff locally, if you need to write to an SD card or something locally, then you absolutely can securely store that. You can encrypt it, and then when it's ready, you can push it up to the cloud. So that shouldn't be an issue.
Okay, I think we got like a message now. Something just popped up on my screen
from one of our viewers.
Oh, okay.
It's
Daniel, thank you so much for supporting us. So the question is, will we support LoRa out of the box? The answer is, I don't know. and let me tell you why. I suspect that very soon after we ship these things, there will be LoRa support. We actually have someone in the community that's already, somebody that's been in our community already that has a LoRa feather wing. So this is a feather form factor, which means that you can drop in
range. Yeah?
Sorry, say that again.
LoRa stands for long range.
Yeah, that's right. So there's so I guess back up a little bit. So LoRa is a gateway connectivity framework or standard. So it's kind of like Wi-Fi or Bluetooth. And there's LoRa and there's WARA, and then there's a whole bunch of other things that are unrelated to those. There's Zigbee and Z-Wave and so forth and so on. LoRa is a long-range communication, radio frequency communication. And there are a number of LoRa boards on the market. And there are a number of LoRa feather wing shields. So this is feather form factor, which is spec published by Adafruit. So you'll be able to plug in a LoRa feather wing, which are what they call shields in this form factor. You'll be able to plug in a LoRa feather wing and then get LoRa connectivity. Now, what I can tell you is that making sure that LoRa works on our platform and specifically the feather wing works is super high priority. And we do have someone in the community that is that in the beta community for us. We have a private beta group that is itching to write that driver. Now I can't promise that he'll get that out, when he'll get that out or when we'll deliver it. But it's definitely something that is high priority for us. I think that LoRa and WARA and also not just LoRa and WARA, but other things like Zigbee and Z-Wave, we need to have really good support for those as well.
Oh yeah.
But I just don't know when we're going to ship those.
That's great.
So I don't want to promise anything.
But I love the way you actually taking something that was existing, but just hitting the refresh button on it and just making it new and actually bring out a new product of it in .NET, which is like my favorite thing, well, .NET Standard rather, and then make it actually production ready. Well, it would be production ready instead of a Raspberry Pi that gets nowhere past the proof of concept stage in my books. Now this thing should be as easy to use as starting a car.
I agree. And actually production, going from prototype to production with, the same code and the same hardware, this was always really, really important for us. So ultimately this is an enterprise play. And this is Meadow. We want Meadow to be embedded in products at scale. And so that meant a couple of design things or design requirements that we've been thinking about since day one. So one of the things about IoT that I mentioned earlier is that IoT will be installed everywhere. So because they can run everywhere, You'll find them out in the forest measuring, measuring climate data. You'll find them, we'll put things like this in space. We'll put them in all kinds of places. We'll put them in buildings where it's hard to get to, where it's hard to reach. And because there'll be so many of them, it'll also be impractical. Even if they're accessible, it's impractical to have physical access to them many times. And so we wanted to make sure that they had a really good over-the-air update and manageability story as well. So we're building a backend for this that will allow you to push updates and manage these devices from the cloud. So the idea there is that if you have new versions, you've added new features, you can push that down over the air, and then you'll also be able to check the health of these things. So you'll be able to see all of these things installed in C2 and be able to take a look at like their battery life, see where their charge is, and take a look at like crash reporting and analysis and things like that. And we wanted to make sure that they work really well with all of the major cloud providers. So whether you're using Azure or you're using AWS or you're using Google Cloud, the idea here is that at scale, this is a real product for the enterprise. And the other thing that we're doing is that we're going to do is so this is a pretty embeddable module, but we're also going to release one that's modules that are even smaller that are not what. So this has what we call through hole, and I don't know if you can see it in the photo there, but there's little holes in where like headers might sit. So here's one with headers.
Yes.
But we're also going to make surface mount modules of these. So the idea here is that they're very small and they just sit on top of an existing circuit, and then they can be soldered down. And so the idea here is that you'll be able to embed this in real products at scale, and massive scale, and be able to manage them at scale as well.
That's important also what they just said. And what about testing? Do you envision something like a IDE that you can go in and sort of draw your board and test it without physically building it? Or what's your opinion on that?
I've seen some cool stuff that's in development around things like that. But we don't have anything on the roadmap right now for that. It's something that we're thinking about. It's something that, is sort of in the big picture, but it's in the parking lot right now.
Okay.
Okay, tell us something. If I buy such a board as a Joe average developer, how does an average developer guy get started with this?
Great question. So what we recommend is, so first of all, everyone that's listening to this, I want you guys to go over to our Kickstarter. I posted the link in there and back us. And what's that?
We'll put it in the show notes as well.
Yeah, absolutely. So go and pledge your support to Meadow. Buy 10 or 20 of the boards. No, but just seriously, I recommend getting the hack kit. And there's two hack kits. There's a hack kit Lite and there's a hack kit Pro. And I recommend getting a hack kit Pro because there's a lot more things that you can do with it, and it comes with some cool stuff like a full color OLED display and things like that the hack kit Lite doesn't have. But the great thing about this, it's the next one down. If you scroll down to the
Kit Lite, was without it.
So that's right. So that has a 4x20 LCD display. But the hack kit Pro, actually, let me see if I can show you my cords and wires everywhere. This is actually our debug board. You see that screen right there? That's a 1-inch 240 by 240 OLED, full color OLED. And it's not in the photo there in the hack kit Pro, but it is in the hack kit.
Is it foldable?
It's not foldable. Not foldable. So get the hack kit, and with the hack kit, we will be publishing a ton of different tutorials and projects that you can build with it. And you can see, actually, if you go to hackster.io, you can already see a bunch of projects and tutorials that we put up. And you can see on the Kickstarter page a bunch of things that you can build with the hack kit. So I recommend going and pledging your support, getting an F7 board, maybe getting a couple boards, and getting the getting a hack kit, and then when it comes to, you'll be able to go online, you'll be able to go to developer.wildernesslabs.co/hackkit, and it will give you, there'll be a fantastic first run experience. So you'll have a fantastic getting started, getting this thing up and running, getting your first application deployed, getting everything configured and building. And then there'll be a bunch of really cool different projects that you can make with it. So imagine our hack kit as like a really fancy Lego Technics set where you can build all kinds of interesting things. That's how I recommend getting started. That way you don't have to go out and source a bunch of that stuff on your own, and it would wind up being more expensive anyway. So definitely get a hack kit and start building.
Cool.
Well, you already mentioned it a bit. The formatting, the current format is like a strip, like a chewing gum strip. How did you get to that format and not square or round or whatever?
So we looked at it's kind of interesting, and actually you can see on our community forums there was a forum post in which we solicited ideas and feedback on what kind of form factor that folks wanted to see this in. And our first inclination was, okay, we'll continue the Arduino form factor, that the big kind of shieldy thing.
Yeah. But
the overwhelming consensus was that that was great back in the day, but folks have moved on to smaller. They want smaller, more embeddable form factors. And Adafruit came out a couple of years ago with this Feather form factor, and it's really, really amazing. One of the things about the Feather form factor is that on this board here, you'll see there's this white connector right here. That's a battery connector. So that you can plug in a lithium, a LiPo lithium polymer, a lithium ion battery, and it's got an onboard charging circuit. And the form factor itself is very, very tiny. It's very embeddable. It makes it possible to put into very small projects, even for prototyping. And so overwhelmingly, people said, look, we want a dual inline package that we can just plug into stuff. And by the way, go look at the Feather form factor because it's fantastic. And so we started looking into it. And I have to say, Adafruit really, they're onto something magical with the Feather form factor. They really did a really good job. Lemore over there, who as I understand designed it, she was really thinking about real world IoT, and I think they came up with something that was really quite magical. And so we started looking into it, and the more that I learned about it, and the more that we started sort of like building around it, the more we liked it. And so that's why we wound up with this Feather form factor.
Right. I read something on your, I think on the Kickstarter, that you had some issues like distributing with batteries. Can you tell something about it? There was a regulation.
Yeah. So one of the things that I really want to do, and it's not out of the question yet, I want to ship a hack kit that is like an add-on to the Hack Kit Pro, which is like a solar hack kit. Oh, yeah. And the idea here is that it has everything in the Hack Kit Pro, but it also adds a solar panel and a battery. And the easy part here is that you plug those things in and they'll just work. And we have an API to check your battery and things like that. So it works brilliantly in terms of like the execution in the application. What's a little more difficult is shipping lithium ion batteries. And I'm not sure if LiPo batteries have the same restrictions, but like lithium ion batteries have a bunch of shipping challenges because they like to explode when they, like cheap batteries tend to, if they get a little bit wet in there's moisture, then they explode. And if you're packing a whole bunch of these into a box and it's on an airplane, when that explodes, bad things happen. And so there's a bunch of regulations around shipping batteries. And so we have to just figure out really what those are and how do we ship these things safely and efficiently to folks. So I would love to have a solar hack kit that has the solar panel, has the battery, you just plug it in and it's good to go. But shipping is a bit of a challenge. That's right.
Was this your first Kickstarter project, or did you have other projects before this?
This is our absolute first.
Right. So, and international shipping, and you're already familiar with that.
Yeah, that's right. So we've shipped quite a bit with, we've shipped a lot of NetDuinos, and we've shipped, as was Wilderness Labs. So we've definitely done that before. Shipping it's expensive, and it's sort of complicated. There's a lot of different rates depending on where you're going in the world and stuff. Luckily, the Kickstarter campaign allows us to put shipping costs in. So we don't, so depending on where you're shipping, we can charge the, international versus domestic. But long term, you'll be able to order these things on Amazon or Mouser, and then shipping is taken care of through there.
And where did you do you outsource production to China, or what is the American product? Where do you create this?
So the Meadow board will likely be assembled in Taiwan. Today we assemble NetDuinos up in Seattle. So there's sort of different. There's a couple different pieces to this. You have to get the PCB printed circuit boards. You have to get those made. You have to source your components, which are all the chips and the capacitors and all the connections and things like that go on. Then you have to get them assembled. The PCB boards all our PCB boards come from Taiwan, who make really so this board is very, very technically complex. There's a lot of what you call high speed signals on there, and you have to have very specific what is a stack up, which is the specification of the layers of the board, and not all PCB houses can make custom stack ups, and not all PCB houses are good. So they might be able to do simple boards, but less more complicated boards. Not everyone can do that. So we've got some really good suppliers in Taiwan that make that. Then the components are sourced actually internationally. A number of what we call jelly bean components, capacitors and resistors and other discretes, those come from China or Japan in bulk. But a number of the chips, the more complicated chips, are actually manufactured in the United States, which is kind of surprising, because a lot of people think, oh, the United States doesn't actually manufacture those things. But it turns out a lot of the big silicon houses are in the United States, and then also in France. So our main microcontroller is actually a French chip. So that's made by ST. So we source all these components, and then we bundle them all together, and then they get assembled. So what that means is that they take the PCB board, and then a pick and place machine, which is this little robot that uses a vacuum head to pick up one of the components and place it, and it goes really, really. It's amazing watching. It's pretty mesmerizing. So those get assembled and stuck on solder paste, which is kind of like a glue. Then they go into an oven, where the oven goes really high temperature, melts the solder paste. Those suck into the metal parts of the components and the pads on the board. And then, then there's some testing and stuff. So these boards will likely be the production run of this will likely be done in Taiwan or Mexico. Right now, like I said, we do them in Seattle. And then the prototypes of these are actually done locally here in Oregon, just outside of Portland.
So your project, I think is echoing, but he's gone. I think it's fine now.
Fanie came in. Came in and left. He was like, I don't want to do this.
He's some issues there, I think. So, and the project is about to end in about 6 days, and you fully completed it. So what's on your Kanban board there on this project? What's next?
Yeah, so that's right. So we got about 6 days left. So last chance to get on, to get your Meadow board if you haven't backed us. The backers will get Meadow boards before anyone else, and I'm not sure how much sooner, but we'll definitely be focusing on delivering to our backers first to make sure that they get them, and that will be. So we're going to deliver those, I think, in February, March timeframe is the current is the current current time frame, and that's going to be what we're calling like a public beta. And so we're running a private beta before then, but the idea here is that we want to ship these out to folks, and we want to get folks the APIs and the software and say, look, this is how we think these things should be done, but we don't want to lock anything down until we're fully validated in the community. And if there's big things that come up, we want to have we want to reserve the opportunity to change them and get them right based on feedback. So for us, the hardware design is effectively done, or essentially we think that it's done. There's still some places in the board that we haven't fully validated, and like various hardware things, but we think that the design is finished. So now it's a matter of finishing up all of the software and getting that stabilized. And so right now we have Mono running on the device. Think of it this way. Right now we have this giant puzzle. It's like a 10,000 piece puzzle, and we've got all these islands built. And now it's a matter of like bringing them all together. So we have Mono running on our board. We have the network stack stuff working and tested. And then we have the framework stuff over here, and a lot of the APIs built, and along with drivers and stuff. And then we have some other various APIs and things like that. So right now we're taking all those things and getting them together and getting them, getting the sort of glue together and working. So the next couple of months are going to be about two things. One is that we are cranking really hard on all of the software here to get all that stuff working and validated, and getting the development experience really smooth. So one of the things right now is that our development experience is not smooth. It's very low level. It's slow. It's a lot of manual flashing and stuff. So we want to get that really, really nice. The idea there is that, and actually, let me show you. I'll show you my screen. Let me show you Visual Studio. So here's an application. The idea here is that you'll be able to write an application using Meadow, and it'll look something like this. And then you select your device up here, and it doesn't work today, but you'll be able to select your device. It'll say Meadow F7 Micro or something, and you hit the big play button. And just like in Xamarin or other types of environments where you're deploying to a device, you hit the big button and it just goes and it just deploys.
Sorry, just a question. So just imagine I receive my device. I'm getting a lot of feedback.
Yeah, there's a lot of feedback from your side.
Hello?
Only if you talk.
Only if I talk. Now, what I mean is, if I receive my device, open it up, do I have to connect it to kind of a wire or Wi-Fi to actually run it? Or my question is more, do I need to connect it with a cable, or can I use it with Wi-Fi to run it, like remote debug this thing?
So out of the gate, so our sort of like V1 experience will be plug it into USB and then deploy that way. Long term, I think we'll support other debug scenarios and other deploy scenarios, but we want to do out of the gate is get just USB, the deploy and debugging working really, really well.
And then once my software is working fine and I've got like thousands of devices out there, how do I roll it out to all 1,000? Do I need to plug it in, each one?
No, not at all. So as long as they have connectivity, you'll be able to use our management tool to send. You'll upload a new package, and then you'll say, you configure which devices that it should go out to. Then you hit the button and it'll deploy. And then we'll also offer an API there as well, so that you can automate that into your CI and things like that.
Cool. So the fully released managed pipeline as well.
That's right. That's right. And since I'm here, let me show you. Let me show my screen again. Let me show you an example of a Meadow application, because I know that we're running out of time. But I think this is kind of cool to see how this works. So this application here, Hello RGB. On the board it's hard to see, but on there is a little tiny RGB LED, and it's a very nice, very high quality LED, and it can run the colors of the spectrum. And so this application basically walks through the hue spectrum and shows a rainbow of colors on that onboard LED. And so this app, let me show you the code that would actually do this. Now, there's some things in here you'll notice. Some of this actually isn't working yet, that we're working on it, but I think it's still good to see how this set up. So first of all, when you're creating a Meadow application, we have this iApp, and iApp is kind of fun because we use generics, and you pass in your device and then the type of your application. And we do this for two reasons. We do some singleton magic in here. And by doing that, you, at any point in your application, you can get access to device, to an instance of the device, and static capabilities of the device as well. So you see here var foo equals device.pins. So at any point, we can like interrogate the device and get whatever IO is on there, and it's all strongly typed. It's really nice. And then also, because we have this, because the device is passed in here, you can actually interrogate other things like capabilities. So here's capabilities, and it's like, well, what are the network capabilities? Does it have Wi-Fi? Does it have Ethernet, etc.? And so that's actually powered through this here. And then you can also do some other things if you wanted it. The idea here is that we're going to have a bunch of different devices, and we want the code to work with various devices really easily. So you can port to other devices that might have different pinouts as well. So you could do a pattern where you actually name, you could say like, whatever my pin, you could say that you, for example, pins might be different between different devices, but you might have the same peripheral plugged into these different devices. And so you could do lookups, you could do pin lookups and things like that, so that you could abstract the device even further. But let me actually show you how this kind of works. So let's say you want to instantiate a peripheral. In this case, we're using the onboard LED, but this could be just as easily, it could be a relay hooked up to it, or it could be a sensor or something. So when I create a new peripheral, they all follow this what we call the unified Gpio pattern. So the idea here is that you can create a new peripheral, and you see the code here, new RGB PWM LED. So if as I actually, let me type this out, you can see an autocomplete RGB PWM LED, and there's two. I'm not sure if it's too small for everyone to see, but there's two constructors. One takes either pins or a port. Now, a pin is the easiest way, and that's like the shortcut. So if I want to create this RGB LED using pins, I say device, and I say pins, and I'm for the red one. For the red PWM, I want red, and then I want the green, etc. And then you wind up with something like this here. Now, the other way that you can do this, you can instantiate this, is there was that second constructor. So new RGB PWM LED, and this time we can pass ports. So in this case, it's pretty easy to create a port. I think I got the wrong. I need to do a using here. Let me just uncomment this. Then using, there we go. So the other way here is that you can create a port, and then you can pass like a pin to create that port. And the reason we do this is there are things, they're called IO expanders. Now, this board is pretty action-packed. It's got 16 digital IOs, and it's got 6 analog IOs on it, so analog pins. But sometimes you want to drive things like big LED displays or other things that require a lot more IO. And so there's these various options to expand IO. They're called IO expander chips, and they're like shift registers, which do digital digital I/O, and there's MCP chips, which will do digital I/O and PWM and things like that. And then there's specialized PWM chips, and then there's mutexes, which will allow a more analog input, etc. So the long story short, the idea here is that you can expand I/O, and we wanted to make it so that when you created a new peripheral, when you created a new RGB PWM LED or an LED, or you created a new relay or something, when you hooked up one of those things, if you hooked it up to an I/O expander chip, programming and using that would be the exact same as if you hooked it up to a pin on the board. And that's why we have these. You can allow you to create from a port. So in this case, if we created a new like MCP I/O expander chip, it would actually give you these ports, and then you simply create your peripheral on those ports. So the idea here is that you can expand the hardware seamlessly. And I think it'll make a lot more sense when you start building this stuff, but I'm pretty proud of it because it's a really interesting architecture that greatly simplifies hardware. And one of the reasons why this is so important is that a number of hardware peripherals actually have I/O expander chips inside of them. So like you mentioned, or we were pointing at that LCD screen earlier on the hack kit. That LCD screen actually uses an expander chip in it to drive the LCD screen, because the LCD requires a bunch of I/O to actually change characters and stuff, but you don't talk to all of those individual pixels. You don't talk to all the characters in that way. You simply talk to the chip, the I/O expander chip that's on there, and then drive that. So by supporting I/O expander chips as like a first-class part of this, that makes it super, super easy to write really fantastic drivers for all of this cool hardware. Anyhow, I know it's a little bit of weedy stuff, so I want to move on.
This is like most of these things are over my head, but it's very interesting to listen to.
If we had more time, I could demystify most of this stuff, or all of this stuff. Really, it sounds complicated, but it's really not. And we've got really good documentation around this stuff to demystify it. It's, imagine the first day you looked at like a view controller in iOS, and you're like, "What is this? This is weird." It's not. It sounds difficult, but it's not. And we're really here to demystify and make this easier. The other thing that I want to show you is that, remember, this is a full .NET application. So you get full .NET, full C#7 stuff. So here we are. I have this method that calls start running colors. And inside here, I spin up a task, and I use async await. And then I call task.start. Now you see we're actually missing a call right here. From HSBA, it doesn't exist in the .NET API, so we're adding it via an extension method, but we just haven't got it in there yet. It's on the to-do. Obviously, it's a very high priority to do because I put 4 to-dos in there. But there's something really magic about this. So I mentioned briefly earlier that Arduino is single-threaded. So this is something like this, first of all, is impossible in Arduino because you've got a single thread. Now, also, the idea of tasks. So task is an abstraction away from threads. The idea of being able to do tasks and abstractions, parallel abstractions like this on a microcontroller is really, really, it's really amazing. If you were writing in C++, you wouldn't have anything like this. You would be dealing with threads, and you would be dealing with your thread pool if you wanted to do some sort of task type stuff, and you would have to, manage all that. But for .NET developers, we have a better framework. We can spin up a task. We don't have to worry about the underlying threads. And the fact that threads are running on here and they're running beautifully, that's really, really amazing. So this is kind of an example of like what a Meadow app would look like. And I think it's just really cool. I think this is some pretty impressive stuff that we've got going on here.
You guys should totally build like a .NET global tool that can go like .NET new Meadow.
That's right. Yeah.
Template kind of thing. That will be great.
Yeah, we will absolutely do that. That's right. So when you get your Meadow board, because I assume that you're going to back us and buy 17
Absolutely.
boards and the 5-pack of
Not 17.
When you get your Meadow board, you'll install you'll run your install, and it'll install the templates into Visual Studio Code, and you'll be able to do file new Meadow application, and then you'll have a template for an app, and you won't have to you don't have to worry about any of that stuff.
Cool. Very interesting.
Yeah. Well, I think we need to invite you for another time when you already deployed all this stuff to all your backers there, and yeah, by then see how it's all going, and see what the production device looks like, and how it's actually adopted by the big masses. Because adoption is the big thing, especially because it's a very cheap item. You have to sell millions of these to get some profit there, I think.
Yeah, that's right. That's right. We definitely got to sell a lot of these.
Right. Well,
we plan on.
Yeah, I'm absolutely going to back this one, and we have 6 days for other people to do the same thing. And well, it was great to have you on the show. And as I said, we would really like to see you back to discuss how the Kickstarter actually went through the complete process.
And also to discuss what's next, because you never know.
Yeah, absolutely. Thanks for having me. I absolutely look forward to being on here again.
Okay, thank you.
Well, next week.
Happy Thanksgiving to all my American friends.
Yeah, next week we'll be at November the 29th, I think. Yes, that's next week. I will probably not be around by then, so one of the other guys needs to pick this up. And see you next week.
Cheers.